Hello, welcome to this Math 125 calculator tutorial. In this video we will be using a TI-30XS MultiView calculator to run a two-variable analysis. The first thing that we will be interested in is putting the data into the calculator. So in this calculator, to input your data, first of all you would like to just hit the data button. And you should have two lists. If you already have data in one of your lists, you can hit data again, and then you can choose which list you would like to clear out just by selecting it and then hitting the enter button. So now that I've cleared out my old data, I'm ready to put the data from this problem in. We're going to put all of the x values, or I guess the temperatures, in the first list. We'll put all of the y values, in this case snow accumulation, in the second list. That's 41, 33, 18, 37, 36, 18, 30, 17, 26, 40. Then going to the y values, we have 6, 20, 23, 8, 12, 26, 28, 13, 18, and 9. Once you've put all of your data in, then we can run our statistic. I'm going to hit second, data, to get to stats, and I'm interested in a two-variable analysis. Alright, our x values I put into the first list, and the y values were put into the second list, so we can just hit enter, 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 and we should see a number of items. First of all, it tells us how many items we plugged in. We could verify that by counting how many rows were in this table. Secondly, we see the mean of the x's, so this is just the average x value. Standard deviation of the sample standard deviation of the x values. The population standard deviation of the x values. The average of the y's, sample standard deviation of the y's, population standard deviation of the y's, a number of other items that might be of interest in some math classes, but not necessarily in Math 125. Then we hit the three items that are really the most relevant for a Math 125 course. That's A, B, and R. So typically, once you have data like this, you can plot a scatter plot to see what type of correlation it looks like you have visually. In this case, it looks to me like we have a fairly weak negative correlation, or you could say a moderately strong negative correlation, but it certainly seems that as temperatures increase, my snow accumulation is decreasing. Maybe there's some intuition to that. The values that we just computed, we can use to answer these questions. So the one that does not need to be computed, that we could have just answered on our own by counting up the rows in the table, is that we have 10 data values. This number is useful because it does get referenced when we answer questions like this final question. The Pearson correlation coefficient is a measurement of how strong the observed correlation is. And that's what R is equal to. So in this case, R is equal to negative 0.638. If the R value is negative, it means you have a negative correlation. If the R value was positive, it would mean you had a positive correlation. The equation of the linear regression utilizes A and B. The format for how we show a linear regression is y hat equals ax plus b. You can compare this to a formula you've maybe seen in an algebra class, which would be y equals mx plus b, and the variables mean the same things, but we denote them differently for regression lines. M is your slope, so that means a is your slope, b is the y-intercept, and that's certainly what b is here. Instead of calling the y value y, we're going to call it y hat. The reason we use y hat is because we're going to frequently use this equation to predict values. And so when we say y hat is equal to something, that just designates it was not one of the original y values we had. It's simply a predictive value. Okay, to do this, let me write in, it would just be y hat is equal to negative, I am going to have to round this slope. It's negative 0.53. I'll just use 2 decimal places here, negative 0.53x plus, and then my intercept is 32.10, 32.10. Once you have this linear regression, you might wonder, should this be used to predict values based on our initial data? So the answer to that question is tied up in the answer to this 4th bullet point here. So we would like to use the R value we computed and a table of critical values to determine if the correlation that we are observing is statistically significant or not. If the correlation is statistically significant, then this equation would be useful to interpolate data at a certain significance level, and then if it's not, then we would it would not be appropriate to actually use this equation that we just found. Okay, let me grab the table. The R value that we just computed is negative 0.63. Let me put this up here at the top of the screen. The table of critical values is going to reference 2 things. It's going to reference a significance level as well as an in value. Now we already know that we entered 10 data points, so we can look across this row in the table to see what the critical values are at 2 different significance levels. The first significance level is 0.05. This just means that there's a 5% chance that assertions we make about the data are not correct. You could think of this as the probability of being incorrect. If you aren't happy with a 5% chance of being incorrect, then we could up our significance level to 0.01. Then you would have only a 1% chance of being incorrect. But you'll see that when we do that, the critical value for the correlation coefficient increases if we want an increased significance level. Well, the question at hand is asking if the correlation is significant at the alpha equals 0.05 level of significance. So what we want to do is we just want to write down this value, 0.632. So the critical value is 0.632. And we want to compare to the absolute value of R. So we're going to rewrite our R value, but we're going to drop the negative sign, 0.638. We can say that the correlation is statistically significant if our R value is closer to 1 than this critical value. Keep in mind that if R was equal to 1 or negative 1, then we have a perfect correlation. Meaning that R values that are closer to 1 are always going to be stronger than R values that are closer to 0. When we look at these 2 numbers, they are fairly similar, but we notice that our R value does beat the critical value from the table, so we can say that yes, the correlation is statistically significant. Well, I hope this video has been helpful in understanding how to use the TI-30XS MultiView Calculator to run a two-variable analysis. If you have a more basic scientific calculator like the TI-30X2S, I have a follow-up video that's linked in the description that will run through doing a two-variable analysis in this basic scientific calculator.